Well, g'day Year 7s, wherever you may be, and here we are for our next video tutorial. This one I think we're looking at exercise 2D, where we're looking at, what are we, transversal lines and parallel lines, and that's a very thick line. I'm just going to adjust that, just bear with me for a minute. Go with maybe that one. Alright, so transversal and parallel lines. Alright, so when a line called a transversal cuts two or more other lines, a number of angles are formed. Alright, so the first thing we're going to talk about before I get to that is what a transversal line. So if we have two lines, as you can see in both these diagrams, so we've got a line going through there, line through there, two parallel lines. Oop, that's really badly drawn, there and there. The transversal line cuts those two lines, okay? So that's what we call a transversal line. So it's that one there, alright, and that one there. That's a transversal. And when you cut lines with a transversal, you end up with different types of angles that are formed. All right. Pairs of these angles and corresponding alternate co-interior angles, depending on their particular position. We'll go over that very shortly. And if the transversal line cuts parallel lines, then there is a relationship between the size of the special pairs of angles that are formed. So there are certain what are we talking about? Relationships or particular things about these corresponding alternate and co-interior angles. All right. Now the lines that the transversal goes through don't have to be parallel. All right. But if they're not parallel, the only way you get these particular types of angles, which I'm going to talk about more in a minute, is when the lines are parallel. All right. I just want to get rid of these ones for a minute. Okay, so like we have here, you only get those angles when these lines are parallel, and you usually tell these lines are parallel because they have arrows showing that they like that on these lines, and that just says that they are parallel, and that means they'll never cross. Just think of train tracks. Okay, they are parallel lines, they never cross. Okay, so these lines, no matter how far you extend them in either direction, okay, that way or that way, they will never cross. So they're just the same distance apart all the way. All right. Okay. First type of angle. So transversal line crossing two parallel lines will form special pairs of angles. So the first one is corresponding. So corresponding. So if we think about corresponding, if I got rid of this line, for instance, and just had that line here and this line crossing it, and an angle is created there. Okay. Now just say, I'm just going to get rid of that now, just say if we got rid of this line and we drew that line and another spot along this straight line, all right, we'd have the same angle would be created, provided that line is parallel, it's the same at the same angle as we originally drew it, it's going to be exactly the same angle. So that's why we call them corresponding, all right. So I just want to get rid of them. Okay, and corresponding can be at different spots. Okay, so you can see in this one corresponding are down here. All right, and I could draw different corresponding here. I'm going to change my color just to sort of demonstrate that if I can. An angle in there and an angle in there. They're corresponding. I'll do another one. Could have an angle in here and a corresponding angle is in there. Okay, and another one. We'll go with blue. Could have an angle in there and an angle in there. They're corresponding. Okay, so it's basically the same angle in a different location because the line's in a different spot, if that makes sense. Okay, and the special thing about these corresponding angles is that they are always equal. Okay, so if this angle here was 120 degrees, this angle was 120 degrees. If this angle here is 30, this angle is 30, and so on and so forth. All right, so that's corresponding. Okay, next one we have alternate. Okay, so they are inside. Alternate will be inside the two parallel lines. So here's our two parallel lines. The alternate angles will be inside, and then also either side of the transversal line that goes through it. Okay. And same with the corresponding, alternate angles are also equal. Okay, they're equal as well. And we've got a couple of examples here. So inside your two parallel lines and on opposite sides, either sides of the transversal line. Okay, they are alternate angles. Next one we have is co-interior. Okay, and again, co-interior are inside the parallel lines. As you'll see in both these examples, the co-interior angles are inside the parallel lines, and different to the alternate angles where they're on opposite sides of the transversal line. The co-interior are on the same side as the transversal lines, and I might get rid of those lines. So as you can see, they are on the same side of the transversal line, okay, inside the two parallel lines, but on the same side of the transversal lines. Now, co-interior angles are a little bit different. They add up to 180, okay, so both these angles will add up to 180 degrees. All right. Okay, so make sure you get all them down on your note-taking sheet, and let's get into some examples. So, first example we're going to do is that you need to name angles. Now, you're naming angles corresponding to the same angle here. So we're looking at ABF. So we look at our points here, A, B, and F. So there's our angle in there, okay? And what you need to do is write the angles using the letters, same way. So the actual, where the angle is going to be a middle letter, okay? Like it is in each of these, A, B, F, okay, B being there. And you need to write down the letters that correspond or alternate or co-interior or vertically opposite. Remember, I've done vertical opposite before, to this angle in here. All right, so I'm going to pause it. I might do the first one with you, and then you can pause it and do the rest. Okay, so the name of the angle that is corresponding to angle ABF. So here, okay, that's the angle we're looking at here. And I might get rid of, sorry, bear with me, rid of that. So there's our angle. So each one is corresponding, so it's got to be in the same spot but at a different parallel line. So there's a parallel line, same spot there. Okay, so that angle for this one would be HF and G. HF and G, or you could also write G, F and H. Doesn't really matter, as long, the only thing that matters is that F is in the middle there, okay, in both these cases. The other two don't really matter which way you go, HFG or GFH. Okay, so that would be your corresponding angle. So what I want you to do now is pause the video and go through the other three examples. All right, okay, off you go. Okay, welcome back. I'm just going to change my colours for these other ones. Okay, so let's do B, the alternate angle to AB and F. So again, ABF, looking at that angle. So what's alternate? So remember alternate, if I can find it, inside the parallel lines and either side of the transversal. Okay, so got to be inside of the parallel lines and either side of the transversal. So if I've got one there, our alternate angle must be in here. Okay, so our angle for that one must be, where are we? B, F and E. B, F and E. Oops. Or we could go E, F, B. Might be the other one. E, F, B. Could be the other way you could write that one. Okay, so that's our angle in there. B, F and E. Okay, and that's alternate or alternate. All right, just want to get rid of these. Bear with me again for a minute. That, all right. Next one, co-interior. So remember, co-interior are on the same side of the transversal and inside of the two parallel lines. Okay, so inside the parallel lines, same side of transversal, so there's our original angle. So our co-interior must also be in here as well. Okay, so that's our co-interior, and they add up to, hopefully you've all yelled out, 180. All right. So there are co-interior angles, or that's a co-interior to A, sorry, I need to write that, A, B and F. So our co-interior here is H, F and B. F and B, or B, F and H. Okay, either one of those are correct. Okay, but it's basically naming the same angle because F is the actual angle that we're describing. And then the last one, and I'll get rid of this particular one here, is we want vertically opposite to ABF. So ABF, so vertically opposite, remember, forget about that line, vertically opposite to this one is looking in here. So we're looking at CBD or DB, sorry, DB and C, that way. All right, and that's vertically opposite. All right, hopefully that makes sense. If you missed any of that, just go back in the video and watch them all again. Okay, next example, find the angle A in each of these diagrams and give reason for the answer. Okay, so using your information back here of your co-interior, alternate and corresponding, you need to give an answer of what each angle is here. And again, you don't get a protractor and measure it. That's not the point. You've got to use the knowledge you have to say what angle A is here. What is it and why? What is angle A here and why? What is angle A here and why? All right, so again, I want you to pause the video, have a go at them, and then come back and we'll work through them together. All right, off you go. Okay, welcome back. Okay, our first one here, angle A, straight out, has to be 115 degrees. And why are we saying it's 115 degrees? Because it is alternate. Okay, and remember, alternate angles are always equal. All right, and we'll just say alternate. Oops, let's fix that up. Alternate. And that looks like an M, but it's not. It's an N. Alternate. This one, straight out, angle A has to be 55 degrees. Why? Because it is corresponding. Okay, this corresponding angle, and if we go all the way back up here, corresponding, basically the same spot, same angle, but on a different parallel line. All right, so same spot, same angle, different parallel line, so that's corresponding. Okay, now last one here, angle A. What type of angle, pairs of angle have we got here? Okay, both on the same side of the transversal, in between the two parallel lines. Hopefully you said, well, that's co-interior. Okay, and they have to add up to 180. So the best way to do that would be angle A equals 180 minus 110. So angle A has to equal 70 degrees. Okay, hopefully you got all that. So because they're co-interior, have to add up to 180. 180 minus 110 must be 70 degrees. So angle A here is 70 degrees. All right. All right. Last example. Okay, remember that we spoke about those pairs of angles only occur if your transversal line cuts two parallel lines. If the lines aren't parallel, you don't get those conditions where co-interior, you can still get co-interior angles, but they won't add up to 180 if the lines aren't parallel. All right, that only happens, those conditions only happen if the lines are parallel. So this question, you need to prove whether the lines are parallel using that information. So giving reasons, state whether the two lines cut by the transversal are parallel. So again, you've got to identify the pair of angle that you have, and then state, well, that means that the lines are either parallel because it satisfies these conditions, or it's not. Okay, so again, I want you to have a go at this on your own. So pause the video, have a go, then we'll come back and work through it together. All right, off you go. All right, welcome back. All right, so look at this first problem. Are these two lines parallel? Okay, well, what type of angles do we have here? We've got alternate angles. And what's the special thing about alternate angles? Okay, they should be equal, shouldn't they? Are these angles equal? 75 and 78. Okay, they are not equal, so the lines are not, whoops, I'll change that, not parallel. Okay, it's that simple. Sorry, spelling's horrendous and so is my writing. Okay, so they cannot be parallel because if that's 75, if they were parallel lines, that should also be 75, or that should be 78. Or either way, it shouldn't matter. But because they're different, that's telling us that these two lines are not parallel. Okay, these two lines, what type of angles have we got here? We've got same side of the transversal inside our parallel lines. So they should add up to, they are co-interior. So they should equal 180 degrees. So let's test it. 122 and 58. We're adding them together. 8 plus 2 is 0. Carry the 1. 5, 6, 7, 8. 1. 180. So yes, they are parallel. Okay. Whoops. Not spelling very well at all today. All right, so they are parallel because they're co-interior. Co-interior, if they're parallel, should add to 180. That's exactly what they do, so they are parallel. All right. All right, hopefully that all makes sense to you. This video's gone a little bit longer, but there's a few extra bits and pieces in there. Hopefully it makes sense. Anything that doesn't, go back over those parts in this video. And again, if you still struggle, come and talk to your teacher. All right, thank you guys. Bye-bye.